Welcome to my presentation. In this presentation, let us look at how to find the difference of two squares. I'm going to explain the procedure, and we will use that procedure to solve some simple example problems in my next video presentation. But now let me explain the procedure. If A and B are real numbers or variables or algebraic expressions, then A squared minus B squared. If we have difference of two squares like that, we can write it out as A plus B times A minus B. A plus B times A minus B. This is the difference of two squares. So for example, if I have an example of this type, if I have like x squared minus 4. Okay, now we want to make sure that every one of the terms is a perfect square. The first term is a perfect square, which is x to the power x raised to the power of 2 is x squared, and then 4 is a perfect square. 2 to the power of 2 is 4. So now I can write this in this formula type. This is the difference of two squares, A squared minus B squared. I'm going to write A, let me write this like this. I'm going to write this one as x and 2 inside the first set of parentheses, and in the second set of parentheses I'm going to write x and 2, and in the first set of parentheses I'm going to put a positive sign between x and 2, and between the second set of parentheses, in the second set of parentheses between x and 2, I'm going to put a negative sign. You can put a positive, you can write it this way too. X minus 2 times x plus 2, doesn't matter, it means the same thing. So no matter which way you write it, one time you want to add the two base terms, and the second time you want to take the difference of the two base terms. So in here, if I were to explain this a little bit more, A plus B times A minus B. A is the base term, we're going to write it twice here, and B is the base term, we're going to write it twice like that there, and therefore A squared minus B squared, we can write it as the sum of, the first time we're going to write as the sum of the base terms, and then the second time we're going to write it as the difference of the base terms. So A squared minus B squared, we can think about it as A plus B times A minus B. Let me try another example here. Let's say we have y squared minus 9. So this is of the form y squared minus 3 squared. 3 squared is a perfect square, isn't it? So therefore this is of the form A squared minus B squared. We know that if we have of this form A squared minus B squared, we can write the sum of the base terms times the difference of the base terms, A plus B times A minus B, and we can do the same thing here. In here, A is y, and then B is 3. Y plus 3, that is the sum of the two base terms, times the difference of the base terms, y minus 3. A plus 3 times A minus 3. Now, we can also go ahead and then check our result whether we are on the right track. If we have A plus B times A minus B, do we get A squared minus B squared? We can check it out. Let's check that. Check A plus B times A minus B is equal to A squared minus B squared. We know from one of the methods which we talked about in the past, which is called the FOIL method. FOIL means we're going to multiply the first terms, multiply the outer terms, multiply the inner terms, and multiply the last terms. And when we combine all of that, we're pretty much using the distribution rule here. When we do that, we should be able to get a squared minus b squared out of this. So let us try that. A times a, we have multiplied the first term, plus a times negative b, we multiplied the outer terms, plus b times a, we multiplied the inner terms, plus b times negative b, we multiplied the last terms. And when we expand this one out, we'll see what we get. A times a is a to the power of 2. A times negative b is negative ab. And then b times a or a times b means the same thing. So I'm going to write it as plus ab. Plus b times negative b is minus b squared. So in here, positive ab and negative ab cancels out, leaving us with a squared minus b squared. And therefore, a squared minus b squared is same as a plus b times a minus b. And therefore, we call this as one of the special forms of polynomials, wherein we can use this formula whenever we see a difference of two terms. Okay, we will use this procedure to solve some simple example problems in my next presentation.